So just talking a little bit more about standard form. You guys are now familiar with two different forms that a quadratic function equation could be expressed in: vertex form and standard form. And from each of those forms, you can state a whole bunch of properties. You can graph the functions. That's basically everything we've done in 2.1 to 2.4. Okay? The only thing I want to add here is that there is another way besides completing the square where you can find the vertex in standard form. And we're actually going to use this way, although you do need to be familiar with completing the square. We're going to use this way when it comes to problem solving with these things. What kind of problems can we solve? Okay, so I'm going to do some algebra. I need you to remain calm because there's going to be lots of letters going on. Okay? All you need to worry about is what's going to happen at the end. But do try to follow along if you can. I am going to take this form and change it to standard form. So the first thing I'm going to do, well, x minus h all squared means the same as x minus h times x minus h. So all I did was expand that. Now I'm going to multiply these two. Keeping in mind this answer all has to be multiplied by a. So I'm going to get a times, and then I do 4 multiplications. X times x is x squared. X times minus h is minus hx. Minus h times x is minus xh again. And minus h times minus h is plus h squared. Okay. Now I'm going to get rid of these parentheses by multiplying everything by a. Or actually, I'm going to simplify inside first. Because what's minus xh minus xh? You guys should know that. What's minus x minus x? Minus x minus x minus x. Negative 1x, subtract 1x. Negative 2x, right? I didn't hear. Okay? Probably because you said, like, that's often how students say it. They don't want to say it too loud. But then if they get it right, all of a sudden they become loud. It's like, I said that. So minus 1 xh minus 1 xh is minus 2 xh plus h squared. Now, I'll multiply everything by a. Believe it or not, this is standard form right now. It just looks very complicated. Okay? All I'm going to do in this next step is, because all these things are getting multiplied, I can rearrange them in any order I want. I'm just going to put the x at the end. Well, sure. When multiplication, the order doesn't matter. 2 times 3 is the same as 3 times 2. Okay? So this is actually standard form, but it looks very complicated. This is A. This is B. And these two things together are C. Because remember, it's something times x squared plus something x plus something. Okay? I'm going to focus on this. B is equal to negative 2A times H. That's what B is. How would I solve for H? How would I get H by itself? How would I get rid of this? Not minus, not plus, because it's being multiplied. Divide by what? Divide by negative 2A to take those out. Divide by negative 2A. So B over negative 2A is equal to H. But isn't H the X vertex? So that means that B over negative 2A, or negative B over 2A, is equal to the X vertex. So you don't have to change it to standard form. You can use this little formula to find the X vertex. And then to find the Y vertex, plug this value into the function and calculate for Y. So you don't have to complete the square. You can use the formula to find the X, plug the X into the function to find the Y. I'll show you. But this is the important part here. So to find the X coordinate of the vertex, because remember, the vertex is the most important part of a quadratic function, we use the formula X vertex equals negative whatever the value of B is, divided by 2 times whatever the value of A is. Once we get that number, we substitute X vertex into the equation of the function. And find Y, or Y vertex. So you actually don't need to complete the square. Completing the square is actually pretty efficient if the quadratic function is simple enough. But when it starts getting more complicated, this actually works better. And again, if we have the vertex, we know everything that's going on with the parabola. We know all the properties and we can graph it. So I just want to look at this example. We're asked to find a whole bunch of properties. Well, we can't read the vertex off of this form right now. So there's one of two ways we could do this. We could either complete the square, or we could use that formula to find the X vertex and then plug it in to find Y. In this case, this method would be quicker. Okay, so looking at the standard form, what's the value of A, the number in front of X squared? 3. What's the value of B, the number in front of X? Negative 12. Don't forget to take the sign. What's the value of C, the number at the end? But we actually don't need that. So to find the X vertex, I take negative B, which is the same thing as negative 12, because remember it's negative b, divided by 2 times a, which is 2 times 3. So what do we get? Which is plus 2. So that means the x vertex is 2. How do we find the y vertex? Take that 2, plug it back in for x here, and calculate y. So the y vertex is going to be 3 times 2 squared minus 12 times 2 plus 5. Well, what's 3 times 2 squared? I thought I heard 12 or 36. Really? Order of operations. And then times 3. So 12 minus 24 plus 5 equals negative 12 plus 5, negative 7. So we got the vertex. It's 2, negative 7. If we were to graph it, does it open up or down? Look at the original. Up, because it's positive. So opens up. Is it a regular one or does it stretch? It stretches times 3. But we weren't asked to graph this one. But if you could graph it. But that's what I always do, and you'll see that in the solutions. I always state the vertex, and then I state, okay, does it open up or down? Is it regular or is it stretched? But let's just state all the properties. What's the vertex? We got vertex is 2, negative 7. What do you want to go to next? If we got the vertex, domain and range. Domain is negative infinity to positive infinity. The range, right. The lowest is negative 7 because it opens up and it goes up to infinity. So negative 7 to infinity. Okay, we got those. Axis of symmetry. X equals 2, yes. Might as well get the max min over with. Min at, yes, y equals negative 7. And then I think we were just y-intercept and number of x-intercepts. Well, remember, for the y-intercept, go back to the standard form. Just plug in 0, and the y-intercept's going to be the number at the end. So the y-intercept is 5. And finally, the number of x-intercepts, you have to think of where it is on the graph. So 2, negative 7, it's down here somewhere, and it opens up, right? 2 x-intercepts. Two x-ins. So you do have to be familiar with completing the square. But really, completing this, like I said, completing the square is useful if the original equations are pretty basic. Once something starts getting tossed in front of the x squared, and if there's a negative there too, this method actually is much more efficient. Okay? Okay.